So again, the big point of this question here, this problem here, is to review essentially the definition or meaning of average velocity and average speed. Okay? Average velocity means the total displacement divided by the total time for the entire trip. Okay? This trip consists of two parts. Average speed, very similar. It's the total distance divided by the total time for the trip. So I've got a trip consisting of two parts. One where the truck travels 4 meters per second north for 12 seconds, and one where it travels 26 meters south for at 16 meters per second. All right, so what I'm going to do is I'm just going to write down the information that I know for both parts of the trip and use that to work towards what I know I need, which are the totals. Okay, I need the total distance and the total time, and the total displacement and the total time. Right? I should be able to get that based on what I already have in the question. Right? So anytime you tackle a physics problem, the first thing you want to do is write down the information given to you by the question. We typically just call that your givens. Okay? So I'm going to write down my givens. For part one of the trip, I know that the velocity is 4.0 meters per second north. Right? I also know that the time for part one is 12.5 seconds. Okay? For part two, I know that the displacement of the truck is 26 meters south, and I know that the velocity is 16 meters per second south. All right, so that's the information I know. I need total displacement. I need total distance. All right, not the narrow over top. And I need the total time. Okay, so those are the three things I need. Right now, I don't have the ability to get either or any of those. Okay, and that's because I don't know how far the object went in part one. Can I find out how far it went in part one? Yeah. Yes, because I have V and T. So I can find D. Right? I'm just going to use this formula, right? V equals D over T. Since I have two of the three parts, I can solve for the one I don't have, which is D. So I'm going to multiply both sides by T and solve for D. All right, so the total displacement in part one is going to be V times T, or 4 times 12.5, which should be 50 meters north. Everyone okay with that? How do I know it's north? Okay, it's positive, and the question told me they were moving at 4 meters per second north. I can't go any direction other than north if I'm going north. Okay. All right, so there, now I have the time and the distance for part one. What am I missing in part two? Time, right? I've got the displacement, I've got the speed. I need to solve for time in part two. If I have the displacement for both parts and the time for both parts, I can get the totals. All right? In fact, right now, I could get the total distance and displacement. All right? I know I went 50 meters north in the first part and 26 meters south in the second part. What's my total displacement? 24 meters north. Okay, so that part's done. How far did I go? 76 meters. I went 50 meters, then 26 meters. Remember, distance doesn't care about direction. It's scalar. Right? So I know my total distance is 76 meters. All right, last thing I need to find is time. So I've got to find the time for part two. T equals D divided by V, so that'll be 26 over 16. All right, so we're looking at 1.625 seconds. Okay, so now I'm going to calculate my total time by taking the 12.5 and adding the 1.625, so I should be looking at 4.125, right? Or sorry, 14.125. All right, so now I have all three things that I said I would need to calculate average velocity, total displacement over total time, and average speed, total distance over total time. So now I can do those calculations, right? My average velocity is my total displacement divided by my total time. So that was going to be 24 meters north divided by 14.125 seconds. Okay, so we're looking at 1.7 meters per second north. Okay, so I just calculated part A. Was it as hard as it looked? I mean, the steps sometimes are hard to figure out, but the math is pretty easy, right? I just had to manipulate the same equation like 4 times. All right, and then the last thing here is I have to find the average speed. All right, speed is scalar, so that's going to mean the total distance divided by the total time. We said the total distance was 76 meters divided by the same amount of time, 14.125 seconds. All right, so we're looking at 5.4 meters per second. Do I need a direction on that? No. In fact, I can't have a direction on that because during that time I went both north and south. All right, is that ringing a bell? I put one like that on my science 10 unit exam last year. Ethan probably remembers it. No, too traumatic. Blocked it out. Yeah. Okay. So this is exactly the kind of thing that we would have done, okay, in Science 10 as a 2-part kind of combined problem for average velocity or average speed. Questions on how that one worked? Okay, so I'm kind of getting the sense that we probably need a little bit of practice on that to kind of get the hang of it again. Right, so what I'm going to do is I'm going to put up a few questions on the board and have you guys work through them, and then we'll go through them together to make sure you've done it right. Okay, so those questions are going to be out of the workbook. So if you go into the Google Classroom and you open up the kinematics workbook file, okay, this is the second page. I'll make it a little bit bigger, but of course you can have it on your phone at your desk if you want. Right, so these are easier than the one we just did. Okay, these are not like 2-part problems. Right, they're just V equals D over T problems. Right, and we'll see how you guys do on those. Right, the answers are here in bold, so you'll know if you did them right or not. Okay, so I'm going to give you guys a few minutes to work through a few of these, and then I'll ask if there's any we need to go through. And don't be afraid to ask if there's one you didn't get. We'll go through it. You're probably not the only person who didn't get it. Right?
Do you by chance have a whole bunch?
There's one over on the table. Okay, so let's say working on 1 through 7 here for right now, and then we'll see how we do on those, and we'll work through a few together in a few minutes. I'll kind of be circling around here. If you got questions, I can help you out. Been recording silence for like the last however many minutes you guys have been working. All right, so number 3, okay, it works a lot like the one we did with the garbage truck. Okay, so we've got a bus that travels 11 kilometers with an average speed of 21, and then travels 1 kilometer at a smaller speed because of highway construction. So we want to determine the average speed for the entire trip. All right, so if we're looking at that, okay, here's what we have. We have part 1. Okay, and in part 1, we know the distance traveled. Actually, we know the displacement, but we won't need it. Okay, 11,000 meters. Why did I change it to meters?
Your speeds in meters per second.
Right, my speed's in meters per second. I have to have my units match. I can't divide meters per second by kilometer or by kilometers. It doesn't work. They're not talking the same language. All right, so I'm converting that to meters. Right, and I know that my average velocity is 21 meters per second. Okay, actually that's a speed because they didn't give a direction on either one of those. So, okay, this is actually distance, this is actually speed. All right, and then part 2, okay, we have 1 kilometer, which is 1,000 meters. Okay, and a speed, because they didn't give us a direction here, okay, of 4.2 meters per second. If I'm going to calculate the average velocity, or sorry, average speed, okay? Average speed is total displacement over total time. Or sorry, total distance over total time. All right, can I calculate my total distance right now? Yeah, it's how much? 12,000 meters. I went 11,000, then I went 1,000, I went 12,000 meters. All right, so we're going to have 12,000 meters, okay, no direction because it's scalar, divided by the total time. That I don't have, but I can calculate it. I can calculate the time for each of the two parts and then just add them together. All right, so to get the time for this one, it's d over v, so 11,000 divided by 21 will give me the time in seconds. All right, so 523.81, we'll say. Okay, and then for this part here, the total time will be 1,000 divided by 4.2. All right, 238.10 seconds. All right, so now I've got the times for the two parts. If I add those two together, I'll have my total time. All right, so we're looking at 761.91 seconds. Okay, so I've got my total distance divided by my total time, right? I'll have my average speed for that one. So 1,200 divided by my answer. All right, so my average speed, that didn't work out. Oh, because I went 1,200, not 12,000. 1,000 divided by 761. All right, so we're looking at 15.7 meters per second as our average speed for that one, or 16 meters per second. All right, the thing that usually throws people off on that one is that one's in kilometers and the other's in meters per second. They just divide them and they get numbers too small. Okay, any other ones giving us trouble there? 2? Okay. All right, number 2, it's a wording thing usually on number 2. This is 2 separate trips and we're treating them separately. We're not combining them in any way. So it just wants to know what's the average velocity for part 1 and what's the average velocity for part 2. Okay, so from the data, determine the average velocity for each run. Well, in the first run, okay, the car travels 604 meters in 2.19 seconds. Okay, and it does that from left to right. Okay, so our first one here, okay, the average velocity is going to be 604 meters right divided by 2.19 seconds. Right, that'll give us 276 meters per second to the right. The second part asks what's for the trip back. Well, the velocity for that one is still 604 meters, but now it took 2.22 seconds, and the direction was reversed. We went back to the left. Okay? So when we do that, we get 272 meters per second left. The wording is a bit confusing, right? Because the average velocity for the entire trip would be 0, because it was 604 meters right and 604 meters left, and the total displacement is 0. All right, any others? How many people are like past number 5 already? Okay, are these ones making sense? I want you guys, whoop, that's not the right one. Okay, and put the marker down. Okay, so for this one here, guys, let's say go up to, do number 7 without the graph. Okay, so go all the way to number 7. You don't need a graph for number 7, and then hopefully we'll get a chance to look at number 8 together, okay, before the end of class. So, okay, let's keep going to number 7. If there's more that give you trouble, just let me know. Okay, coming around to help you. So if you're having trouble, I'll help. Okay, how many people are done up to number 8? Okay, so I want to look at number 8 right now. So we'll kind of walk through that, kind of just follow along with me on number 8 as we kind of go through how that one works. It's about as involved as a V equals D over T question would ever get. Okay. All right, so I have a car that is making a trip that consists of not 2 but 3 parts this time. Okay, everything's in kilometers and kilometers per hour, so we don't have to worry about changing any units around. Okay, everything is already in matching units. But what I do want to do is break it up into its parts. So in part one, or sorry, the car makes a 60-kilometer trip. All right, that means the total distance traveled is 60 kilometers. Okay, actually 60 kilometers north, so it actually is a displacement. All right, and that takes, oh, sorry, they do that at an average velocity of 40 kilometers per hour north. And the trip consists of 3 parts. The car moves with an average constant velocity of 25 kilometers per hour due north for the first 15 kilometers. So it's talking about part 1. Right? So my velocity there is 25 kilometers per hour north, and it does that for 15 kilometers. Okay, everybody kind of following what I'm doing here? Just reading the question and writing down what the question is telling me. All right, in part 2, the car moves with a constant velocity of 62 kilometers per hour. And for the next 32 kilometers. Okay, and then it says, with what velocity does the car travel? So we're looking for this during the third part, okay, which is, it tells us, 13 kilometers. Okay, if I'm going to find out what V is in part 3, what else do I need for part 3? Time. Okay, so I need to find the time for part 3. All right, can I find the time for the other 2 parts?
Yes.
Okay, will that help me? Yes, because I can also find the total time, right? They told me the total displacement and the average velocity for the entire trip. So the first thing I want to do is find out how long the whole trip takes. Okay? If I can find that, and I can find the time for 2 out of the 3 parts, I can figure out what the last remaining amount of time is, and that'll help me calculate the velocity for that last one. Everyone kind of follow my logic? Okay. So the time here, okay, is going to be 60 kilometers divided by 40 kilometers per hour, d over v, right? That's 1.5 hours. All right, so the whole trip takes 1.5 hours. All right, back to this one, got to do the same calculation. T equals d over v for just this part. So that'll be 25 over 15. All right, so we're looking at 1.67 hours. Okay, and sorry, that's not right. What did I screw up? Oh, I got it backwards. That's why I screwed up there. It's 15 over 25. Sorry, guys. 15 over 25. That's going to be a much different number. Okay, 0.6. All right, so we got 0.6 hours. Okay, and then same calculation here. T equals d over v. That's going to be 32 divided by 62. All right, 0.516 hours, we'll say. Okay, so I've got the time for 2 out of the 3 parts, and I know the total. How do I find the time for part 3? Exactly. Add part 1 and part 2 together, then subtract that from the total. Whatever time is remaining is the time that part 3 takes. Yeah, so I'm going to have 1.16 hours is my total time. Well, I should go 1.5 minus 1.16. All right, so that leaves me with 0.34 hours. Now can I find V? Yeah, because V equals D, which I have, and T, which I now have. Right, so when we do that, okay, we're going to have 13 divided by 0.34. So, I don't know why I have 0.34 kilometers per hour north up there, but okay, we got 0.34 hours on that one. Okay, everyone okay with that? All right, so that'll be about as involved as they'll get in terms of a problem involving V equals D over T. We're not going to do a lot of problems involving V equals D over T for March because that's for DP Science 10. Okay, we're just kind of doing this to flex our algebra muscles a little bit and get back into the groove of doing that. Okay, so starting next week, okay, we're going to start looking at graphing. Okay, so we're going to be looking at position versus time, velocity versus time graphs. Then we'll probably look at vector addition, and then we'll go into acceleration from there. So for the next 2 weeks or so, okay, we're going to be doing graphing and vector addition, then we'll move into acceleration. Okay, be ready to do some trig by late next week. And that's what we'll do.